Today's lesson is the continuation of representing, naming, and evaluating functions, day 1. The first day we tackled this lesson, we talked about function and not a function. Now we're going to go back to our same notes, and we're going to fill in all the information about domain and range. So let's first look at your opening exercise. You had already done this, determining which ones were a function and not a function. If you recall, exercise 1 was a function because each input has one output. Every element in the input side only has one arrow coming from it. Remember that it does not matter that 1 and 2 have 2 arrows going to it. It's all about input having one output, which therefore then made number 2 not a function. So now we want to define what it means for domain and range. Domain of a function is the set of all inputs. Okay, so we're going to underline that. It's the set of all inputs, or in other words, the x values that you're allowed to use for the function. If I was going to give an example of this, I will use the opening exercise. In number 1, my set of input values, or x values, are the set A, B, C, and D. Those are all of my x values, or the elements of my domain. In number 2, my input, or x values, or domain would be 1, 2, and 3. On the other hand, we have range. Range is going to be the set of all outputs. The set of all outputs, or in other words, your y values. If I were to list my range for exercise number 1 in the opening exercise, it would be a list of all of my output values, which are 1 and 2. In number 2, it would be the list of all my output values, which would be A, B, C, D, and E. Now, one way you can remember which one is which is think about the way a coordinate is set up. X comes before Y in the alphabet. Also in the alphabet, D comes before R. So the domain is for the X and the range is for the Y. So alphabetically, just like the coordinate. So now we're going to go down to our examples that we've discussed in the previous lesson, and we are going to add in information about the domain and range. So looking at the first example, we want to think of domain and range as how much can we pinch the graph before we start to overlap the pieces. I will try to show you a similar thing by using a highlighter. Okay, so let's start with domain. Domain are your x's. So you want to make your hands or your highlighters look like the opposite of the x-axis, which is the y-axis, so another vertical. You want to pinch from a vertical perspective until you can't anymore. And when I go to try to pinch here like you just see, you're going to notice we have a problem. These arrows are going to go into my highlighted region. So I'm actually not able to pinch that graph at all, which means my domain or my x values is all real numbers. If I were to draw this arrow is going to keep going on and it's going to go to more and more x values this way. This arrow is going to keep going on and go to more x values this way. So for the domain, you're going to think back to your set notation and remember that because our domain for x values are all real numbers, we're going to use the set notation for real numbers. So in parentheses, put a reminder to yourself what that means. All real numbers. Now when we go to talk about the range, which is our y values, we don't want to make our hands look like the y-axis, vertical. We want to make them horizontal, and we're pinching from the bottom and the top to see how far we can go. So if I use a highlighter, I notice I can go all the way up to right here, and none of that area that I just highlighted is a part of my graph. Yet when I try to do it this way, and I work my way down, remember that eventually this arrow is going to come way over here, and it's going to go up into my highlighted region. So that tells me there's no upper boundary for my y values. So for the range, I want to make sure I see that my lower bound is the highlighted and I can go up forever. So when I list my range, I want to list all the values that I can use. And by looking at where I drew the highlight, I can see that -3 is my cutoff for my lowest value, and all the rest of my y values are above that. So that means I want y is greater than or equal to -3. If I were to write that in interval notation, that tells me -3 is my lower bound and infinity is my upper bound. So we'll put or so that you have both options there. Now let's look at the table of values. We want to know our domain and our range. This one's a little bit different because we have specific values in our table. So remember, the domain are our inputs or our x values. So for my domain, I'm going to list my elements. I have 0, 2, 8, and 18. Now they do repeat. I have 2 18s, 2 8s, but I do not need to list them more than once. For my range, I will list all of my y values or my outputs. So there I have -3, -2, -1, 0, 1, 2, and 3. Now let's move on to our next page, go over these domain and range values. In the top left, we had a list of coordinates. We saw that 4 went to all of those things, so it was not a function. However, if I go to list the domain and range, remember domain is the set of x values or my input. So my domain here is just the number 4, so I can just list that in my set alone. My range is all the list of my outputs or y values. So here I have 0, 1, 2, 3, 4, and 5. So as you can see from our examples, some of our domains and ranges are finite sets. For example, if I go back to the table of values, my domain is finite. There's 1, 2, 3, 4 values. Whereas if I look at the graph, I have infinite sets. The real number system and the fact that y is greater than or equal to -3, those are example of infinite. So you can have either one when you're talking about domain and range. Now let's look at the equation f of x equals the square root of x minus 7. If you recall in the previous day's lesson, we made a graph of this to see what was going on. So I can use my strategy of pinching. I can't pinch coming from this way because the arrow is going to overlap it. However, if I go to pinch this way, I can pinch all the way up to that number right there, which is a 7. Okay? So that means that my domain can be anything that's a 7 or bigger. Now, another way to look at this would be to look at the table in your graphing calculator. Okay, so on your graphing calculator, here's the picture of the graph that we sketched from. And if I hit second graph, it'll take me to the table. And I notice that I have this error message all the way up until I get to the number 7. That tells me that that's where my x values start. And across from it, it's also telling me where my y value starts. My lowest x is a 7, my lowest y is a 0, and I can use that to determine my domain and range. So going back here, now we know our domain is going to be x is greater than or equal to 7, including the 7. Or in other words, in interval notation, that would be from 7 as the lowest up towards infinity. 7 is included, infinity is not. For our range, when we looked at our table of values, across from 7 was a 0. So now we know our y values can be anything greater than or equal to 0, or in interval notation, 0 is our lowest, it's going towards infinity. 0 is included, infinity is not. Now let's talk quickly about why that happens for our domain. If I were to put another value in that was less than 7, let's say I put in 6, I would get the square root of 6 minus 7, which would be the square root of -1. And we know we're not allowed to have the square root of a negative number. So that's really what that table of values is telling us and pointing out to us so that we can write the proper domain and range. All right, our last one is the application question. It says the assignments of PE teachers to students, and we already have this set up. So the domain's a little bit different here because we wrote down a few examples of students to see what was going on, but technically this question is about the entire middle school, and there's no way that we could list all of those students. So for our domain, we're going to put the grade 6 through 8 students are the input. What we drew was a sampling of how it would work just to get an idea of whether it would be a function or not. For our range, however, though, our output values, there are only 4 options of PE teachers. So we would list those. We would list DeWolf, Latini, Lasher, and Easton, and we would end with set notation. And that concludes our lesson on representing, naming, and evaluating functions day 1, but part B.